This is lesson 4-4, Proving Triangles Congruent by the SSS and SAS method. So some new vocabulary terms that we want to talk about is the included angle. And to be included means that you're with something or between something. So that is our only new term. So if we have an acute scalene triangle on a piece of paper and we label its vertices A, B, C on the interior of each angle. If I go through some steps and I draw a segment that's congruent to AC and I label it endpoints D and E, and then I take segment AB and I construct a segment that's congruent, and I take a segment that's congruent to CB and I rotate it a little bit to find where they intersect. If I then make that point F and I connect my sides, now I have created sides that are congruent. I can translate this on top of triangle ABC, and I see that all of the parts match up, and I have 3 congruent sides. By showing that if I have 3 congruent sides, this suggests the postulate of SSS, which stands for the side, side, side postulate. And the side, side, side postulate states if 3 sides of one triangle are congruent to 3 corresponding sides of another triangle, then the 2 triangles are congruent. So again, if I have triangle ABC and triangle RST, if I know that AC is congruent to RT, and I know that AB is congruent to RS, and I know that BC is congruent to ST, then I can write a congruence statement that says triangle ABC is congruent to triangle RST. This allows us to use 3 parts instead of matching up all 6 parts. SSS stands for side, side, side. If 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. If I have 2 triangles, and I know that segment ZY is congruent to segment FE, and I know that segment XY is congruent to segment DE, and I know that segment XZ is congruent to segment DF, I can write a congruency statement. So if I need to draw this to see it, I can say that ZY is congruent to FE, and I mark them as such. XY, I'm going to add point X and connect it, and then I'm going to add point D and connect it. And I am left with XZ is congruent to DF. So since I can see that all of my sides are congruent, I know that this is congruent by the side, 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 or SSS postulate, and I can say that triangle ZXY is congruent to triangle FDE. The reason that it says sample answer is because I can rearrange these points. I can say triangle XYZ is congruent, and then I just have to match up the same sides. Well, X corresponds to D, so it would be to triangle D, and Y corresponds to E, and Z corresponds to F. So this is another sample answer. But notice, Z and F are in the same spots. Z and F are in the same spots. X and D are in the same spot. Well, X and D are in the same spot. Y and E are in the same spot. That lets me know that those answers are both acceptable. This leads us to the SAS postulate, which states if 2 sides and the included angle of one triangle are congruent to the corresponding sides and included angle of another triangle, then the triangles are congruent. So SAS stands for a side, an angle between them, and another side. So again, if I have triangle ABC and triangle RST, if I start with side AC, that's going to correspond to side RT. And angle A is going to correspond to angle R. And the next side, because it's side, angle, side, would be that AB is congruent to RS. Angle A is considered included because the sides are the sides of the triangle. The sides of angle A are the sides that bracket it. So A is included because it is between the two sides. R is included because it is between the two sides. This leads us to the following congruency statement, that triangle ABC is congruent to triangle RST. It is assumed that if these two sides and the angle between them is congruent, that the rest of the triangle will be congruent. So if we have a piece of paper and we think about determine whether the triangles are congruent by SAS, if so, write a statement of congruence and tell why they are congruent. If not, explain your reasoning. So here are my two triangles. I have a side, an angle, and a side. And I can see that angle P is included between segments QP and RP. It is between them. The sides of the angle are the sides of the triangle. If I look at triangle FDE, I see here's a side and here's a side, but angle D is not included. Angle D is not included because if I go side, angle, the other side would be over here. So this is not included because FE is what is labeled. So therefore, I do not have enough information to say that this is congruent by side, angle, side. And again, remember, it doesn't matter what it looks like. You can only use the information that is given. And again, D is not the included angle for DF and EF. And I can tell that it's not included because it's angle D. Here's DF, but this is not DE. In order for it to be included, the vertex needs to be shared in both segments. Here is an example. Determine which postulate can be used to prove that the triangles are congruent. If it is not possible to prove congruence, choose not possible. Well, here is a side, an included angle, and another side. Here is a side, an included angle, and another side. So that is side, angle, side, or SAS, side, angle, side, or SAS, and therefore C is my correct answer. Here is an example for you to try. The reason that it is SSS, or side, 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 is that this side and this side is congruent, this side and this side is congruent, but there is a hidden third side. The hidden third side is this diagonal that is shared by both. Well, it's the same segment that is shared by both triangles, and it's congruent to itself, which means that I have three sides that are congruent, so therefore they are congruent by SSS, or side, side, side. The reason that this is not possible is because the angle is not included. In order for the angle to be included, it would have to be here. And there is no postulate or theorem that allows us to use two sides and a non-included angle. The correct answer is B, because AB corresponds to RS and AC, first and last, corresponds to RT, which is first and last. If the angles are congruent, then I need to know the sides, because it is side, angle, side. Therefore, I know the angle, I need to know the other two sides. That concludes Lesson 4-4, proving triangles congruent by side, 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 and side, angle, side. Please do not forget to bring any questions you may have to class.